This video is sponsored by PCBWay. More on them later. Oh, I didn't realize that we were rolling already. I just got out of hair and makeup, hence the look. Let me fix this. So there's definitely volume, but I think just the way I did these curlers / my layers kind of make it give mushroom top. Let's just clip it back a little. Fix this. You can see the ends have a little bit of a curl. That's nice. That's kind of what we're looking for in terms of the benchmark for these 3D printed curlers we'll try today. In this video, we will be exploring if 3D printing can be used to style my hair. Particularly, can we replicate a Velcro hair curler? The video will be broken down into the following sections, and timestamps will be included in the description below. So when we consider a traditional hair curler, it's made of a Velcro. Fundamentally though, it's just a cylinder, and pardon my beautiful art skills, a cylinder with a bunch of tiny hairs poking out, which I continue to call throughout this video prickles. So these prickles are all over the part, very small, and are essentially what helps grab the hair onto the curler. I didn't want to have to sit there and model every individual prickle, so I started doing a little bit of research. This was initially inspired by the furry lion print. That prints like this takes advantage of bridging between an outer shell and the actual part which is within that shell. Scrolling into the description of this video, I found Drew Loop Flowers by Mark Peters, which is a Thingiverse link, and this guy made an OpenSCAD script to leverage bridging and create these droopy loop flowers. So to make my curler model, I basically took his code, learned a little bit of OpenSCAD, and retrofit it to create my curler geometry. So let's go through that code. So just like I showed with the hairy lion, I also took advantage of a supporting wall to help kind of create my curler prickles. If I had not added the supporting wall, all of these would just droop down at this length. I'll show you a close-up of one curler I tested where I didn't use a supporting wall, and I made shorter prickles so that they wouldn't droop as far, and although it turned out very well, it doesn't really grip on to my hair strand as much as if I was to create longer prickles, then add a supporting wall, bridge between the two, and then trim that supporting wall off after. This particular code file, along with Mark Peters' Droopy Flowers link, will be included in the description in case you'd like to play around with it. I used his code as a base and added my changes to account for the center hollowed out cylinder, which is the core of the curler, to create these longer prickles that repeated all over the length of the curler, and then to add an appropriate supporting wall, which gets cut off after printing. So the key parameters here that I included is the curler height. I also mentioned my curler inner and outer radius. I indicated where the prickles should start on the curler, how long each of the prickles are, the width of the prickles, so 2 bead widths, assuming that my nozzle diameter is 0.4 millimeters, so the width of the bead coming out would be 0.4, and I'm accounting for starting from the curler, coming to the support wall, then going back from the support wall to the curler. So 0.4 times 2, 0.8. I've made my prickle height, my slice height being 0.2, as well as the angle at which each prickle interfaces to the curler, which is 90 degrees. Then all this code here about how the prickles are generated circularly around this curler has been taken from the flower source code. So for example, if I wanted to change my curler height, I would come here at the top and change my curler height variable. Then I would generate it just like this to show my new model. We can see that the curler is now a lot shorter. I can also change the radius of my curler, which I did explore by making larger and smaller curlers for different parts of my hair when I style it. I can also change this twist angle that I forgot to mention, which is the twist angle between each layer of prickles. So as the prickles start from the curler and move down, they actually rotate around. Each prickle has an offset and is not built right on top of a previous prickle, if that makes sense. I can also change the number of of prickles. So if I decrease this number, let's see what happens. Changing it to 1 decreases the amount of prickles I have on each layer. Then if I were to increase this number, say to 10, that would modify the density of the prickles that I see. So essentially, if I wanted a better gripping curler that holds onto my hair, I would increase the amount of prickles that I have on there. But as you had seen, I had 4 here and I felt as though that density was fairly good through experimentation. The diameter of the supporting wall is also something I played with to variable print time, as well as to minimize how much material I was wasting, considering the support wall gets cut off as well as part of the prickles. So the prickles don't necessarily need to be this long. I noticed that these 3D printed prickles, or like faux hook Velcro, they don't cling onto my hair as well as traditional Velcro, which makes sense. But one workaround is to create longer prickles, longer than the traditional curler, so that it grabs onto the hair a lot better than with the shorter prickles. Who knew so much consideration would go into the design of a curler? For the sake of this demo, I'm going to readjust some of these parameters and then show how I sliced this curler. I would like to modify this parameter by modifying the P length variable. Here, I'm able to change the length of each prickle and then consequently change the diameter of that supporting wall. Once my preview looks like what I want, I'm going to hit render. Now that my model has rendered, I can go ahead and hit this little STL button to export the model as an STL file. When it comes to printing flexible filaments, I like to do it on my Prusa i3 Mark III's Plus, which is back there. I'm currently in Prusa Slicer. I can go ahead and open my newly generated STL. Here is my curler, prickles, and supporting wall ready to go. One note is that I'm printing at a 0.2mm slice height. In this case, I can change it to the larger slice height available for my nozzle. That would save me some print time, but if I do change to the 0.3mm slice height, I need to make sure that in my OpenSCAD model, I change the prickle height to 0.3 to account for that new thickness. I basically just select NinjaTech NinjaFlex TPU for this print. I've modified the nozzle temperature here to just fall in line with the TPU I'm using, and then I hit slice, and basically this is the print that I'm working with. So on the first layer, there's no prickles. Moving up, we start generating each of one of those prickles or curler hairs. Just like this, each layer has 4 of them, and then as we move up the curler, they offset 33 degrees layer by layer, which fills up the curler just like this. This is a 2.5 hour print. One thing to improve print time is decreasing the amount of prickles you have, but that might affect how well the curler grabs onto hair, or using a thicker slice height, but that might need some play to see how the material will droop, particularly for these prickles that will now be thicker height-wise. Now this curler is ready to print, which gives me the perfect segue for our video sponsor, PCBWay. If you're working on a project and don't have direct access to PCB fabrication or 3D printing services, PCBWay might be a great resource for you. If you couldn't tell by this channel, I'm somebody who deeply loves 3D printing, whether it be exploring different technologies or pushing the boundaries of what can possibly be made. On that note, why I'm particularly excited about PCBWay is the access to certain types of printing like SLS that I can't access within my resource circle, which opens a wide range of project ideas, plus their online user interface is fairly easy to use. Let's check it out. Once you've entered the PCBWay site, this is what I see. Up here on the menu, we've got PCB quotes, CNC and 3D printing, PCB assembly, electronics design, and a bit more. So we'll be covering the 3D printing services, but as you can see, they've got CNC machining, multi-axis milling and turning, which is lathe, sheet metal fabrication including laser cutting, bending, and post-processing, as well as injection molding, rapid tooling, multi-cavity molds. Keep in mind though that when it comes to injection molding, it's quite costly considering you also have to fabricate the mold core. Under the 3D printing services, there's quite a bit. They've got SLA, DLP, FDM, which we all know as our filament fabrication, selective laser melting, selective laser sintering, polyjet, and also vacuum casting. So let's check this out. It's just as easy as pulling in the STL file. You've got a 3D view where you can double check what your part looks like. I can then go and change my quantity, and it gives me an estimate estimated price, my design units, the type of material I want to use, so we'll hit TPU. Let's go with black TPU. Oh, I can do SLS. So here's food for thought. Do you think that an SLS curler would print a lot better because of the powder being in between to support each prickle instead of just relying on the bridge gap feature between curler and supporting wall? You can also make comments about threads and tapped holes inserts, marking on the part. You can laser engrave or silk screen if there's any assembly, and then there's some notes about printing risk, etc. So let's say I want one. Obviously one piece is going to be quite costly. This resource is great if you don't have direct access to certain materials or printer technologies, particularly in SLS. But for a future video, I hope to be exploring something in metal. So stay tuned for that, and thank you to PCBWay for sponsoring this video. I thought it could be pretty interesting to look at the different curlers under a microscope. So this is the original Velcro curler. As I mentioned earlier, it's the hook side of hook and loop Velcro, and you can see how these little plastic pieces look exactly kind of like hooks. Let's take a look at some of my 3D printed curlers. So this really small one is one of my first tests where instead of using the supporting wall, I just did really short prickles and they ended up kind of drooping because of the lack of support, and you can see they look more like loops. Now this does kind of grip onto hair, but not as well as if they were hooks. Clearly, I could go in and snip each individual loop, but that just does not make sense, really. Another version was this larger curler. I experimented with some shorter prickles. You can see still kind of form loops just because no supporting wall. They droop again because of the lack of supporting wall. The shorter the prickle and the more improved your tooling is, the more upright they kind of print. And the interior is a bit rough. If you remember in the actual OpenSCAD model, I had the prickle kind of cross over the interior of the curler a bit. This is a closer look at the curler with a supporting wall still. And you can see on the inside it's also still a little globby because of the CAD model. Now here's a look at the 3D printed curlers after I've cut the supporting wall off. So this curler has a bit of the longer prickles. You can see it's very disorderly. I wonder if I just blow it a little bit with hot air if they'll get a little curl and look more like those hooks on the original traditional curler we looked at with the Velcro. Looks kind of just like fake grass. So this blue one is a flexible PLA blend. It's like a copolymer. Then I printed it with this white TPU. Now this TPU, clearly you can see it needs to be dried. It has a lot of stringiness, and the inside is pretty bad in terms of that string. Either it needs to be dried or I was printing it way too hot. It could be a combination of both. Kind of looks like cotton candy in here. Here is the black Ninja Flex TPU. I think this one turned out by far the best. Look at how clean these prickles are. You can even see very clean TPU layers. It's a very interesting top view. You can see the roughness on the inside of the part, and here are the prickles. Very clean with this material. I'm going to actually quickly heat the surface of this with some hot air and see if these curl a little bit to look more like the traditional Velcro curler. So the hot air idea didn't really work. It kind of just flattened the prickles. Like you can see a few of them curled a little bit, but this is not optimal for a curler. Even trying to apply the heat a bit from a distance didn't really curl the tips like I was hoping for. It more of just flattened them. Oh well, let's see how these really work as curlers. We need to take the curler from this to this, and to do that, basically I need to free each of these prickles or bridges from the outer shell. So I shove my scissor basically down here, trim, and then I go around the perimeter and I just cut each of the little bridge passes. They go all the way around until the outer shell just comes right off, and I'm left with this nice and flexible curler, which the fact that it's nice and flexible may or may not work in our favor in terms of keeping the structure of the curl, but we're gonna find out. At least for sure, this flexi curler will be guaranteed more comfortable to sleep in compared to the harder curlers. I finished trimming all of my curlers. In terms of the larger size ones, I have 4. I have 2 of these skinnier, taller ones, and 5 of these medium, shorter sized curlers. I used, as you can tell, 3 different flex filaments. This was just based on what I had available. So some of these curlers ended up really stringy, and I think if I had dried the TPU before printing, it would have come out a lot better. In terms of curling my hair, I don't really know what I'm doing. I had to look up a tutorial, but all I do know is that I need to take like a section in the front together and curl it under on a big curler. I'm going to basically take every section and use this hot brush to comb it out and then put it in the curler, and I will secure my hair in the curler using one of these metal clips, styling clips. I'm sure I could have even printed a simple like living hinge clip like this to use to make the styling fully 3D printed, but I had these. I think this is probably like the most embarrassing video that I'll have up on my channel. The thing is that I have a lot of hair. I definitely need a lot more rollers, but this looks really good. Like it really grabbed the hair in this thinner section. Alright, I missed a piece here, but this is the best that I'm gonna get. Got 1, 2, 3, 4, 5, 6, 7, 8, 9 curlers in my hair. This is it. This is how I'm going to go to bed, and we'll see how it turns out in the morning.
The next morning.
Good morning. This is what we're working with after sleeping like 6 or 7 hours. The bottom sock curl I had came out, but I still have a little bit of wave, which is nice. This curler, the ends came out. If I had more clips, it would have been a lot better. It was extremely comfortable to sleep in. None of the curlers that I printed actually came out. The white and blue one, they're slightly stiffer and there's more stringing in between the bridges. And I actually think that made it a better curler. It acted more like Velcro than these black ones, which kind of slipped through my hair. Definitely the more clips the better, and it's a lot easier with these smaller curlers and smaller, thinner sections of hair. I guess just for the kick of it, I should show you the back too. I have literally no idea what it looks like, so sorry for the jump scare in advance. Yeah, this one definitely fell out. I can feel it. Yeah, this one on the very back. Alright, it's already looking pretty promising. The unfortunate thing that I'm starting to realize though is I think these clips left kinks in my hair, so I definitely need to get clips that don't clamp as hard because it kind of deformed this, especially how I slept on it. So this is the moment of truth. You know what? It needs a little bit of fixing, but it's not that bad. I'm just saying that so that I can tell myself the results are actually good. Maybe. But I like the volume. How bad is it? Back. Honestly, from 3D printed curlers, look at the volume. Really not bad. I don't think it's that bad. Would I do this every day? Probably not. I don't think that these curlers can tighten as tight and hold as the actual Velcro curlers, but they were really comfortable to sleep in, and they didn't tear my roots out when I took them off or when I was sleeping, so that's a bonus because normal curlers are really uncomfortable for me. Okay, let's talk about what I would have done differently for the hair curler design. This is our original hair curler, a hollowed out cylinder with a bunch of prickles printed from a flexible filament TPU. So most of the curlers that I printed were thin wall. Having a thin and flexible curler will be comfortable to sleep in, but the problem is it's easily squished, so it doesn't retain its round shape. When you sleep and apply pressure on it from your head on the pillow, etc., it can kind of squish out the curler. It left the curler kind of bent. One idea to improve this is that out of a stiffer material, print another hollow cylinder and put that inside of this curler. So if we look at a side view, we have the outside curler with all the prickles, and then on the inside we have that stiffer curler. This also reduces print time because we're not printing a thicker TPU curler, and it saves some material with respect to our flex filament. The problem with this is that by creating a stiffer curler, it is now less comfortable to sleep in. In the very beginning of this video, the intro was with traditional hair curlers that are made from a hard plastic and have that Velcro on them, and that was extremely uncomfortable to sleep in. One thing I very much appreciated about 3D printed curlers was how comfortable those were to sleep in. Now, another idea for this curler would be, instead of printing a hollow cylinder, these are the prickles of the curler, to actually create an inner cylinder and add spokes to support the outer cylinder, similar to a wheel rim where it has the center core and the spokes. This would take more time and material to print, but would offer more structure to the curler without compromising how comfortable it is to sleep in. Whether we do this spoke idea or we actually trick the slicer to print some kind of infill pattern within the hollow cylinder. By printing a lower infill pattern, we will actually still have gaps to put our hair clip in to hold our curler once it's been in our hair. So these are two improvements. This one could be added into the OpenSCAD file, and this one would be a slicer trick. I did previously post a YouTube short regarding the 3D printed curlers, and a few of you guys commented some suggestions, which I took into consideration for these ideas, and I'd just like to say thank you for your contribution. So I did actually print a curler prototype with the supporting wall in PLA, and there was a few things that I noticed and didn't like about this curler. First of all, the prickles did hold their shape a lot better, but removing the external wall by cutting through each of these prickles made such a mess. I noticed that for some reason those in the PLA and the stiff material did not stay attached as well to the center core of the curler and would just fall off while I was like cutting through. Also, I noticed that a lot of the prickles fell off and got stuck in my hair while I was using the curler. I did not notice this problem with any of the flex materials. The prickles seem to bond a lot better to the center core than in the PLA that I tested. Also, I would fear that the stiffer material would crack with me sleeping on it, considering the curler is a pretty thin cylinder. So yes, you can style your hair with 3D printing.